Last fall, I started a series of videos about improving the air intake system on the LS2 powered C6. Since then, like a dog chasing a squirrel, or in this case, like me attempting to chase science, the project has taken quite a few twists and turns. It all started when I noticed how high the intake air temperatures were getting when I was stuck in stop-and-go traffic, and how long they were staying elevated, which is quite detrimental to horsepower, by the way. And then I was looking at the stock air intake system and I thought to myself, why did the GM engineers design it in such a way that it sucks the air in from so high up inside the engine bay, where the air temperatures are the highest? Then I remembered seeing how GM had completely redesigned the LS3 and the LS7 powered C6 Corvette's air intake system, and how it appeared to be much freer flowing, and it also clearly picks up air from a little bit further forward, but way down low in the underhood area, where physics tells us the air will be cooler. Then it also dawned on me that I remember seeing my buddy Ben's C6 Z06. It has the aftermarket Haltech Killer Bee air intake system, which includes Haltech's Hive. The Hive part is designed specifically to isolate the underhood engine heat from the part of the air intake system where the air is ingested into the engine, and I'm pretty sure they did that because they were aware of the physics that says for every 10 degrees the air is cooler, the engine makes roughly 1% more horsepower. So last September I decided to build my own heat shield to isolate that hot engine bay heat from the part of the air intake where air is ingested into the filters, and I got pretty far, basically to what I would call the prototype stage. Then I decided I needed to make sure that the heat shield itself wasn't going to become a restriction to flow, and after some quick testing I confirmed that it wasn't. Then I decided I might as well go a step further and do some additional resistance to flow testing of the air filter assembly itself, and I did that with the air filters in place. I did it with simulated dirty air filters, and I also did it without the air filters in place. And the bottom line is, at the end of the day, I was very impressed with how well the stock LS2 air filter assembly, including the paper filters, flowed. Then I did some additional analysis and determined that if the 1/2 pound per square inch of resistance that I was seeing between ambient air pressure and what was inside the intake manifold was coming from the air filter assembly somewhere, it had to be coming from the LS2's stock mass airflow sensor assembly. And that, my friends, led me down yet another rabbit hole, and that was to upgrade the whole air filter assembly to the revised LS3, LS7 style air intake filter assembly, including the upgraded card style mass airflow sensor. So at that time, winter was fast approaching, and so I did just enough tuning to make sure it was running rich enough and that it wouldn't be experiencing any knock. Then I proceeded to do some careful back-to-back testing between the LS2 air intake assembly and the LS3, LS7 assembly, and what I found is that the LS3, LS7 assembly had roughly 1/10 of a pound per square inch less pressure drop than the LS2 assembly did. To be completely blunt, I was a little disappointed in this result. I was hoping for more of a reduction in the pressure drop between the two systems, but nonetheless, it is a step in the right direction. And by a little quick and dirty math, it equates to about 4.2 additional horsepower with the stock LS2 engine, and of course it would be worth more if the engine was modified. That having been said, we still have the second main benefit of swapping to the LS3, LS7 style air intake assembly, and that is its ability to draw in that cooler, denser air from down low in the front part of the engine bay. And so now it's time to finish off that heat shield that we started with the LS2 air intake assembly. As it turns out, it just took a couple of rounds of laying out the heat shield in place, putting down some masking tape, marking it with a marker, and then of course trimming it with the snips and then power tools to get it shaped to where I wanted it. Next, it was time to permanently attach the side panels to the top part of the shield. So I took a piece of aluminum stock, cut it into 2 short pieces where I made a simple bend followed by a little bit of sanding, and then I drilled holes so that I could attach the sides to the top with rivets. The completed heat shield is finally in place, and I think it looks pretty good. The total cost is a little less than $300 for all the parts and materials that I used. And of course, if you had to pay somebody to do the tuning aspect, that would cost a little bit more. To give the heat shield a quick test, I took the C6 for about a 20-minute ride to let everything fully warm up. Then I parked it and let it idle for about 2 minutes. Then I popped the hood, and using an IR temperature gun, I checked the temperature in the vicinity of where the stock LS2 air intake would typically draw in its air. Then I lifted up the heat shield and checked the temperature of where the LS3, LS7 air intake assembly was ingesting its air. If I did my math correctly, then the new setup is taking in air that's about 30 degrees cooler than the old setup, and that should equate to around 12 horsepower, which isn't too bad. What else could I do to improve the air intake assembly on the LS2 powered C6? Well, the fast LSXR 102 intake manifold is said to be worth around 20 horsepower on stock LS2s. However, it is one expensive chunk of plastic, coming in at around $1,150. Another thought that crossed my mind would be to port the existing stock LS2 intake manifold. The internet circles say that that's worth somewhere between 5 and 10 horsepower. A larger throttle body crossed my mind, as it might pick up a few horsepower. However, finding one that's a quality unit and doesn't cost $700 would be a challenge, and I don't like spending that kind of money without a documented horsepower return expectation. Anyway, this little air intake science experiment is finally complete, and the question that's likely on the table is, would I do it again? Yes, I would, but that's probably because I didn't have the added expense of doing the tuning involved for that card style LS3, LS7 mass airflow sensor. If I had to pay for that tuning, I'd probably go with an aftermarket air intake assembly that draws in the air from down low up front, uses the stock LS2 mass airflow sensor, and then I'd probably just go ahead and make my own heat shield. Well, that's a wrap on this one, guys. If you liked the video, tap that thumbs up below. Leave a comment so we know what you think. Subscribe so you don't miss the next video. But most of all, thanks for watching.